Hello everyone, my name is Mr. Amoyavi and I am one of your grade 12 advanced maths teachers. As you can see, I've got a question that reads, given the triangle ABC, find y. Now we are given a triangle, so in order to solve a triangle problem, we see if the triangle is a right angle triangle or not a right triangle. Right, so as you can see, it's not a right triangle or a non-right triangle angle. So if a triangle given is not a right triangle, then we think up cosine rule and sine rule. We can't use Pythagoras theorem to solve this. We can't use the trig ratios to solve this. So the only option we have is either the cosine rule or the sine rule, because if you are to fit in this information, this angle, if I have 120 here, then this angle here will be 60 degrees. So there is no right triangle or right angle. All right, so the best way to look at or solve this problem is to write out the simplest is the sine rule. So we can write the sine rule as, starting with this side here, we are given this angle and the opposite side is 4. So we can write 4 over sine 60 degrees, which will be equal to, okay, the unknown is y, so we write y over sine of 100 degrees. Right, this is an equation, so we just cross multiply and solve for the unknown y here. So we leave the y as it is, and it's a division, so we multiply both sides by y. So we get 4 sine of 100 over sine of 60 degrees, which is equal to y. Now, once you reach this part, you have to use your scientific calculator to evaluate this part. 4 times sine 100 divided by sine 60. And make sure that your calculator or the scientific calculator is in degree mode. Sometimes your calculator will be in radian mode, and once you enter this information, it won't give you the correct result. So make sure your calculator is in the degree mode. So once you evaluate this part, 4 sine 100 divided by sine 60, y therefore will be equal to approximately 4.55. All right, so the correct answer here, the correct alternative here is A. All right, so what we have basically done in this problem is we are given a non-right triangle, so we used the sine rule to solve this problem, and the value for y is 4.55. Next question will be a short answer question that we are going to look at. So before we do that, we can quickly take this or rub the board out, and then we can answer that. Thank you. Hello and welcome back. We're now going to look at a short answer question on trigonometry again. And the question that we have here reads, if cos theta is equal to 0.58, find theta given that theta lies between 180 degrees and 360 degrees. Now we are asked to solve this equation. We are going to start with the idea of quadrant angles. Right, as you have learned, the quadrants are labeled in counterclockwise direction. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Right, this is 0 degrees, this will be 90 degrees, 180 degrees, 270 degrees, and 360. If you complete one complete revolution, then it's 360. All right, so the other thing that we have learned is about the ASTC rule. Here, this quadrant has got all the acute angles, angles less than 90 degrees. And if you're going to work out the rather trig ratios for all the angles here, you will end up with positive. So sine, cosine, and tangent, they are all positive. That's why we say all. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. In the last quadrant, cosine is positive. This is the equation that we are required to solve, and the angle theta must be found in 180 and 360. So if you are going to solve this, cos theta is equal to 0.58, right? All you have to do is, using your scientific calculator, you will have to take the cos inverse of this number and you'll find a value for theta. And make sure that your calculator is in the right mode, and that is in the degree mode. So using your calculator, theta will be equal to cos, again it will be shift cos, and then 0.58. And so theta now will be equal to about 54.55 degrees. And if you are to round it off to the nearest whole number, you get 55 degrees. Now, as you can see, we have this question here, and we got the value for theta, but we are required to find the angle theta in between 180 and 360. So if you look at the quadrant, all is positive here for the first quadrant. In the second quadrant, only sine ratio is positive. In the third quadrant, only the tangent is positive, and in the fourth quadrant, only cosine is positive. All right, so we can say this angle is for this value for angle theta here. 55 degrees is only for the first quadrant. And we know this is, if you want to find the angle in between 90 and 180, you will say 180 minus the theta that we are calculating. Okay, for the third quadrant, it will be 180 plus the angle theta that we are calculating. In our last quadrant, 360 minus theta. Right, so the angle that we are required to calculate is in between 180 and 360. So the angle theta will be only in these two quadrants. But we see that in the third quadrant, tangent only is positive. And you look at this one, cosine is positive. So that means here it will be negative. So the only quadrant that we will have cosine positive is the fourth quadrant. Therefore, to find establish our final answer, theta is not equal to 55 degrees according to this restriction or the domain that we are given. So we will say 360 minus theta, which is 360 minus 55 degrees, which will be equal to 305 degrees. All right, so that is the answer. That is the value for the theta that we are required to find here. So theta is equal to 305 degrees. Now, if you want to prove that your answer is correct, you have to also use your calculator and enter cos of 55 degrees. You will get approximately equal to 0.58. Or if you are to evaluate cos of 305 degrees, you will end up with the same result. And that shows that your answer is correct. So thank you. That's how we solve our question like this, using the idea of quadrants that you have learned to find the value of the unknown theta. All right, so thank you. In our next lesson, we're also going to continue with some questions on trigonometry. Thank you.